Every decision you have ever made might have spawned an entire cosmos. This is not science fiction, but a serious possibility at the heart of multiverse theory. For too long, this idea has been trapped in dense equations and academic debates. We are here to change that. By the end of this journey, you will possess 25 shocking secrets that will permanently alter your perception of reality. We will uncover why the fabric of our universe might bear scars from a collision with another, and ask if you are truly alone or just one version among an infinite crowd. Are you ready to question the very nature of existence? The first secret begins not with a starry sky, but in a quiet graduate student's office in the 1950s. A young physicist named Hugh Everett III proposed an idea so radical it was dismissed for decades. He dared to ask a simple, terrifying question. What if the strange rules of the quantum world, where particles exist in multiple states until observed, apply to everything? His answer, the many worlds interpretation, is our first shocking secret. It states that every single quantum event, every choice, every random atomic decay does not settle on one outcome. Instead, reality itself splits like a branch on a cosmic tree. In one branch, the atom decayed at that exact moment. In another, it did not. Both outcomes are equally real, creating two separate, parallel universes that proceed independently. This means a universe where you took that different job offer absolutely exists, spinning off from the moment you made your decision. Another universe exists where you never even watched this video. Everett's work was met with silence and scorn from the scientific giants of his day, a rejection so profound he eventually left academia. Yet today, his theory is experiencing a monumental resurgence, not as science fiction, but as a legitimate and compelling solution to the deepest puzzles of quantum mechanics. It paints a picture of a reality endlessly forking, a vast, branching tree where every possibility is realized somewhere. This leads us directly to our next unsettling revelation. Everett's branching universes exist within the same fundamental framework of reality, but what if the laws of physics themselves were not universal? This brings us to our second shocking secret, a discovery not in quantum labs but etched across the entire night sky. The theory of cosmic inflation proposes that a fraction of a second after the Big Bang, our infant universe underwent a period of unimaginably rapid expansion, stretching far faster than the speed of light. This explains why the cosmos looks so uniform in every direction. But here is the profound twist. Most cosmologists now believe this inflationary period did not start and stop neatly in one place. Instead, it is likely eternal. Think of a pot of water beginning to boil. One bubble forms, then another and another. In this cosmic model, our entire universe is just one bubble that formed and stopped inflating, allowing stars and galaxies to form within it. But outside our bubble, the inflationary process continues forever, constantly spawning new bubble universes. Each of these bubbles is a completely separate cosmos, pinched off from the others, drifting apart in an infinite, frothing sea of spacetime. This is the inflationary multiverse, a cosmic foam where every bubble can have different properties. The fundamental constants we take for granted, the strength of gravity, the mass of an electron, even the number of spatial dimensions, could be set randomly as each bubble forms. In some bubbles, gravity is so strong that stars collapse in moments. In others, atoms never bond and chemistry is impossible. Our universe, with its perfect balance for life, is just one lucky bubble in an endless ocean of mostly barren, inhospitable realities. We are not just one universe among many similar copies. We are a single, fragile island of stability in a chaotic, infinite ocean where the rules of existence are rewritten with every new bubble. This raises a chilling and inevitable question. If we are surrounded by an infinity of other worlds, could any of them be close enough to touch? This perfect balance is not a comforting sign of design, but a terrifying cosmic riddle. It is known as the fine-tuning problem, and it is our third shocking secret. The fundamental forces and constants that govern our universe appear to be dialed in with impossible precision. If the force of gravity were even slightly stronger, stars would burn out in a cosmic blink. If it were weaker, galaxies and stars would never have formed at all. If the nuclear forces that bind atoms were a fraction of a percent different, carbon, the essential building block of life as we know it, would not exist. The list of these razor-sharp balances goes on and on, each one a necessary condition for a universe that can support complex structures and, ultimately, observers like us. The odds of all these dials landing in the perfect configuration by pure random chance are astronomically small, so small that it feels like a cosmic miracle. This is where the multiverse offers a profound and humbling explanation. In an infinite, eternal, inflationary sea of bubble universes, every possible combination of physical constants will be realized somewhere. Most of those universes are sterile, dark, or collapse instantly, but by the sheer law of large numbers, a few will, purely by chance, have the right recipe. We find ourselves in one of those rare, habitable bubbles not because it was made for us, but because we could not exist anywhere else. This line of reasoning is formalized in the anthropic principle. The weak version simply states that our observations of the universe are constrained by the fact that we exist to observe it. We see a universe compatible with life because we are here. The strong anthropic principle takes a more controversial step, suggesting the universe must have properties that allow life to develop at some stage. The multiverse provides a natural, physical mechanism for the weak anthropic principle. We are not the purpose of the cosmos. We are a statistical inevitability in a cosmos of infinite variety. Our existence is not a lucky accident in a single universe, but an absolute certainty across an endless multiverse where every possibility, no matter how unlikely, must happen. This realization forces us to confront an even stranger possibility about the nature of reality itself. But this cosmic lottery of physical constants is not the final frontier of reality. The fourth secret pushes the multiverse concept into a realm so abstract it challenges our definition of existence itself. This is the mathematical multiverse proposed by physicist Max Tegmark. His idea is deceptively simple yet utterly revolutionary. If a universe can be described by a self-consistent mathematical structure, then it exists as a physical reality somewhere. Think about that for a moment. Our universe runs on the mathematics of general relativity and quantum mechanics. Tegmark argues that this math is not just a description of our cosmos. It is our cosmos, and by that same logic, any other mathematical system, no matter how strange, corresponds to a real, physical universe. This means realities with 5 spatial dimensions, or where time flows in loops, are not just thought experiments. They exist, universes governed by geometries we cannot visualize, where circles have corners and parallel lines constantly meet, are out there. Even more bizarre, this could include universes where the fundamental logic is different. A world where something can be both true and false at the same time, not as a quantum superposition, but as a basic fact of existence. This level 4 multiverse is the ultimate ensemble. It contains every single bubble universe from cosmic inflation, every branching timeline from quantum mechanics, and then goes infinitely further. It houses every possible reality that math can conceive. Our universe, with its 3 dimensions of space and 1 of time, is just one page in an infinite library of mathematical possibility. We are not just one island in a sea of other similar islands. We are one sentence in a book that contains every story that could ever be written. This leads to a profound and personal question about our own place in this vastness. If every mathematical structure is real, then somewhere in a universe describable by a different set of equations, there might be another version of you. Not a quantum twin from a split decision, but a being constructed from entirely different fundamental substances, following alien rules of physics, yet still representing the complex pattern that is you. The you in that universe might be a swirling cloud of conscious gas in a 15-dimensional space, but it would, in its own framework, be real. This idea stretches the concept of identity to the breaking point and forces us to ask what truly makes us us. Is it our specific atoms, or is it the abstract pattern of information that we represent? Tegmark's vision suggests that in the grandest scheme of things, we are patterns first and physical beings second. This mathematical framework doesn't just add more universes to the catalogue, it redefines what a universe is. But if all these bizarre realities are out there, pressing against the edges of our own, could they leave a mark we can actually detect? The silent tug of a hidden neighbor might be the most direct evidence we have ever glimpsed. This is the fifth shocking secret, a phenomenon astronomers call dark flow. Picture the expansion of the universe as a vast, calm river carrying all galaxies apart from one another. Scientists expected that on the largest scales, this motion would be random and evenly distributed in all directions. But when they studied the motion of enormous clusters of galaxies, they found something impossible to ignore. Hundreds of these massive structures, each containing thousands of galaxies, are all streaming in the same specific direction at incredible speeds, like leaves caught in a secret current the river itself cannot explain. This motion defies the uniform push of dark energy and the pull of all known matter in our observable universe. It is as if something immense, lying far beyond everything we can see, is exerting a gravitational pull on our entire cosmic neighborhood. The most breathtaking hypothesis to explain dark flow is that we are feeling the influence of another universe, just beyond the ultimate horizon of our own bubble cosmos. In the infinite froth of the inflationary sea, another bubble universe may exist close enough that its mass tugs at the fabric of our reality. We cannot see it because light from that universe has not had time to reach us since the beginning of time, but gravity, weaving through the very substrate of space-time, might provide a ghostly signal of its presence. This idea is, of course, fiercely controversial. Many scientists propose more conventional explanations within our own universe, such as vast, undiscovered structures or peculiarities in the data. The search for answers continues, with new telescopes and surveys designed to map this mysterious flow with ever greater precision. If dark flow is confirmed and its extragalactic origin proven, it would be a monumental discovery. We would have not just a theory, but an observation, a fingerprint left on our cosmos by another reality entirely. It would mean our universe is not an isolated island, but one piece in a closer, more interactive cosmic archipelago than we ever dared to dream. The notion that we can feel the presence of another cosmos changes the multiverse from a philosophical idea into a potential feature of our physical landscape. And if universes can brush against one another in the dark, what other, more violent interactions might be possible? The ghostly pull of dark flow hints at a cosmos that is not alone, but it does not prepare us for the sixth secret, a revelation about the very nature of our own reality. Some of the most brilliant theoretical physicists working today propose a staggering idea, the holographic principle. It suggests that everything we perceive in our three-dimensional universe, every galaxy, every planet, every one of us, might be nothing more than a complex projection. A hologram, the information needed to describe every particle and force within our cosmos, is not stored throughout its vast volume, but is instead encoded on a two-dimensional surface that surrounds it, like the shimmering information on the surface of a bubble. Think of a DVD. That flat, circular disc contains no tiny actors or miniature landscapes, only a pattern of microscopic pits. When you play it, a projector decodes that two-dimensional information and creates the illusion of a rich, three-dimensional movie on your screen. The holographic principle argues our universe operates on a similar, but far more fundamental, scale. We are the three-dimensional movie. The true reality, the source code, exists on a distant, two-dimensional boundary we can never see or touch. This is not a metaphor for consciousness, but a serious proposal arising from the clash between quantum mechanics and gravity at black holes. It resolves profound paradoxes about how information is preserved in the cosmos. Now connect this to the multiverse. If our universe is one holographic projection, then what about the bubble universes floating in the inflationary sea, or the branching timelines of the quantum world? Each one could be its own distinct projection, a unique three-dimensional movie generated from its own two-dimensional code. Picture an infinite cosmic library, but instead of shelves of books, it holds an endless collection of these shimmering boundary surfaces. Each one a flat page in a grand codex containing the complete instructions to render an entire reality. We are not just one universe among many, we may be one projection among an infinite gallery of them. This transforms the multiverse from a collection of separate places into a library of possible simulations, each running on the same fundamental hardware of reality. It begs a haunting question: if we are a projection, who or what is running the projector, and what happens if the code that defines us encounters a glitch? The holographic code that renders our reality may be more fragile than we think, leading to a secret so unnerving it questions the very nature of death. This is the thought experiment of quantum suicide. Imagine a modified version of Schrödinger's famous cat experiment, but with a conscious human participant. You are placed in a box with a device linked to a radioactive atom. In any given second, there is a 50% chance the atom will decay. If it decays, the device releases a deadly toxin. If it does not, you hear a harmless click and live another second. The experiment resets automatically, repeating this lethal gamble every single second. From an outside observer's perspective in a single universe, this is a straightforward death sentence. Statistically, you would be dead within minutes. But from your own subjective experience inside the box, in the branching reality of the many worlds interpretation, something profoundly different happens. Every time the device activates, the universe splits. In one branch, the atom decays and you die. In the other branch, it does not, and you survive to hear the click. Your conscious awareness can only follow the branch where you continue to exist. No matter how many times the quantum trigger is pulled, you will always find yourself in the sequence of branches where the lethal outcome never happens. From your first-person perspective, you would hear click after click after click, surviving against all conceivable odds. You would have achieved a bizarre and terrifying form of quantum immortality. This is not a recipe for invincibility in our daily lives, as most deaths are caused by macroscopic, determined events, not pure quantum randomness. But for a death tied directly to a quantum event, the theory suggests your conscious experience would never include the moment of your death. You would always jump to a timeline where you miraculously survived. The philosophical implications are staggering. It suggests that for any being whose existence hinges on quantum chance, death might be an illusion experienced only by outside observers. Your own story from the inside might never end. This leads to the obvious and crucial question: why don't we see evidence of this macabre immortality in the world around us? We do not find old people who have miraculously survived thousands of near-certain lethal accidents. The answer lies in the nature of probability and branching. For every version of you that survives a 1 in a billion chance, there are billions of other branches where you did not. The overwhelming majority of your conscious copies cease. While one thread of your existence continues against the odds, you, as the collective entity across the multiverse, are still almost certainly dead. The surviving version is just one thread in an infinite tapestry of endings. Furthermore, as you survive increasingly improbable events, the branch you inhabit becomes exponentially more strange and isolated from the familiar flow of history, a timeline growing ever more divergent and lonely. So while quantum immortality presents a chilling logical consequence of many worlds, it remains a subjective phantom, a secret of perspective rather than a practical truth. It forces us to ask what consciousness really follows through the branching tree of reality, and whether the self is a single thread or a scattered multitude. This dizzying view from inside the box makes the solidity of our own history feel suddenly precarious. Our precarious thread of consciousness leads to a paradox so profound it undermines the very evidence of our own existence. The eighth secret is not about other universes, but about what might spontaneously appear within the infinite chaos of any one of them, given enough time. It is called the Boltzmann Brain paradox, named for the physicist Ludwig Boltzmann, who first grappled with the statistical nature of reality. The core idea stems from a simple law of thermodynamics that systems tend toward disorder. But in a universe that lasts for an eternity, even the most improbable events become not just possible, but inevitable. Given enough time, random quantum fluctuations in the empty vacuum of space could, by sheer astronomical accident, cause particles to assemble into any configuration, no matter how complex. This includes the exact arrangement of atoms that constitutes a fully formed, conscious human brain, complete with a lifetime of false memories floating alone in the void. This disembodied observer would snap into existence, believe itself to be a person living on a planet called Earth, experience a few moments of coherent thought, and then almost immediately dissolve back into the random chaos from which it came. In a truly eternal and vast multiverse, the mathematics becomes terrifying. The spontaneous, random formation of such isolated brains would be vastly more probable than the slow, arduous, and incredibly specific evolutionary process that led to our actual planet, our solar system, and our billions of interconnected ancestors. There are simply far more ways to randomly assemble a single, self-deluded brain than to build an entire consistent cosmos with a continuous history. So the shocking question the paradox forces us to ask is this: are you more likely to be a real, evolved being reading this script, or are you a momentary Boltzmann brain, hallucinating this entire reality, including the memory of starting this video from the absolute nothingness of a random quantum field? The logic seems inescapable and deeply unsettling. If the multiverse is eternal and infinite, then statistically, you should almost certainly be one of these phantom observers, not a genuine product of cosmic history. This is not a thought experiment about simulation, but about raw, spontaneous generation from chaos. The most common rebuttal to this dizzying idea is an appeal to our shared reality. We have consistent memories, we interact with a complex world that obeys stable laws, and we receive new information from outside ourselves. A Boltzmann brain would be a brief, solipsistic flash, unlikely to experience a long, coherent, and corroborated narrative. Our experience feels too rich, too detailed, and too persistent to be that fleeting accident. Yet the paradox remains a serious challenge for certain models of an eternal multiverse because it highlights a catastrophic failure of prediction. If a theory suggests that the most likely observer in the cosmos is a disembodied brain in the void, and yet we clearly are not that, then perhaps the theory itself is flawed. It forces cosmologists to seek models of the multiverse that are not truly eternal in the past, or that have other mechanisms to make ordered, evolved observers like us more probable than random statistical ghosts. The Boltzmann brain paradox serves as a cosmic reality check, a reminder that infinity breeds not just possibility, but profound absurdity. It asks us to trust the continuity of our world, even as the foundations of reality seem to suggest we should not exist at all. And if our own sense of self is so statistically fragile, what does that imply for the solidity of everything around us? The statistical fragility of our own existence forces us to confront a possibility that feels ripped from science fiction, yet is taken seriously by some of our brightest minds. This is the ninth shocking secret, the simulation hypothesis, but viewed through the lens of the multiverse. The argument, popularized by figures like Elon Musk and philosopher Nick Bostrom, begins with a simple premise. If any civilization in the cosmos reaches a post-human level of technological maturity, it would likely possess the computing power to run vast, detailed simulations of conscious beings within their own history. These simulated realities, or ancestor simulations, would be indistinguishable from base reality to those inside them. Now, if such a civilization runs even a modest number of these simulations, the number of simulated conscious beings would quickly dwarf the number of original biological ones. Therefore, if you are a conscious being, you are statistically far more likely to be a simulation than a flesh and blood creature in the original reality. This is the classic simulation argument, but now inject the multiverse. In an infinite inflationary sea of bubble universes, or within Tegmark's mathematical multiverse, it is not just possible, but absolutely certain that countless civilizations have reached this technological stage. In some universes, the laws of physics might make computation trivially easy. The result is not just one civilization running a few simulations. It is an infinite number of advanced cultures, each potentially running an infinite number of simulations. This creates a digital multiverse, a staggering hierarchy of realities nested within realities. Our cosmos, with all its galaxies and mysteries, could be a simulation running on a computer in another universe, which itself might be a simulation in a higher-level reality. This chain could go on forever. From this perspective, the simulation hypothesis is not a separate idea. It is merely one specific flavor of a broader multiverse. A simulated reality is just another type of universe, one whose physical laws are programmed code rather than fundamental fields. It exists within the grand ensemble. And if simulated realities vastly outnumber base realities across the infinite multiverse, then the probability that we are in a base reality plummets to near zero. We are almost certainly living inside someone else's or something else's creation. This is not necessarily a cause for despair. For us, inside the simulation, the laws of physics are consistent and real. Our joys, our struggles, our discoveries are no less meaningful, but it does add a new layer of mystery to the fine-tuning we discussed earlier. Perhaps the physical constants are not dialed in by a cosmic lottery, but carefully chosen by a programmer to allow for complex structures like stars, planets, and conscious life to emerge within the simulation. The universe's mathematical elegance might reflect the elegance of its underlying code. This idea transforms our search for a theory of everything into a search for the source code of our particular simulation. And if we are in a simulation, a haunting question remains. Are we a historical research project, an entertainment, or something else entirely? And more importantly, could we ever find a glitch in the system that reveals the truth? Our search for the universe's source code leads us to the most mathematically elegant framework ever conceived, and to our 10th shocking secret. String theory proposes that the fundamental building blocks of reality are not point-like particles, but unimaginably tiny, vibrating loops of energy. The different vibrations of these strings give rise to every force and particle we observe, from gravity to gluons. But for this beautiful math to work, it requires extra dimensions of space, curled up so small we never perceive them. The shape of these hidden dimensions is everything. It dictates the laws of physics in the larger universe, much like the shape of a trumpet determines the notes it can play. And here lies the profound revelation. String theory does not predict one unique shape for these dimensions. Instead, it allows for a staggering number of possible stable configurations, perhaps as many as 10 to the power of 500. This is not a number you can truly comprehend. It is more than the total number of atoms in our entire observable universe. This is the string theory landscape, a cosmic terrain of possible realities so vast it dwarfs imagination. Picture an endless alien mountain range with countless peaks and valleys. Each valley represents one possible stable configuration of the extra dimensions, one self-consistent set of physical laws. Our universe, with its specific strength of gravity and mass for the electron, is just one valley in this infinite landscape. We are not special. We are simply one possible outcome in a near-infinite array of mathematical possibilities. This landscape provides a physical mechanism for the inflationary bubble multiverse. Each bubble universe, as it forms, could settle into a different valley in this landscape, locking in its own unique physics. String theory doesn't just allow for a multiverse, it practically demands one, offering a near infinity of blueprints for reality. The fine-tuning we marvel at is no longer a miracle, but a simple consequence of our location in the landscape. We exist in a valley that allows for chemistry, stars, and life. Countless other valleys are barren, their physics incapable of supporting any complex structure. This vision transforms our cosmos from a singular creation into a single page in the ultimate catalogue of existence. A catalogue written not in words, but in the hidden geometry of extra dimensions. The mathematical landscape of string theory offers infinite possibilities for reality, but it also raises a practical question about the nature of change itself. What if the most famous paradox in all of science fiction is not a paradox at all, but a blueprint for creation? This is the 11th shocking secret of the multiverse. Time travel, the act of journeying to the past, might not alter your own history. Instead, it could instantly spawn an entirely new universe. Think of the classic grandfather paradox. You build a time machine, travel back in time, and prevent your own grandfather from meeting your grandmother. If you succeed, you would never be born, which means you could never have built the time machine to go back in time in the first place. It is a logical loop that seems to make time travel impossible. The multiverse shatters this loop. In the many worlds framework, the moment your time machine arrives in the past, you are not entering your own timeline. You are stepping into a new, parallel branch that splits off from that historical moment. In this new branch, your actions unfold freely. You might indeed prevent that fateful meeting. In that new timeline, a version of you will never be born. But crucially, the original timeline you came from remains untouched and unchanged. In that universe, your grandfather did meet your grandmother. You were born, you built the time machine, and you disappeared into the past, never to return. Your home history continues safely without you. This transforms a time machine from a vehicle of paradox into an engine of genesis. Every journey to the past does not rewrite history, it writes a new one. It becomes a universe creation device. This idea elegantly resolves every classic time travel headache. What if you go back and give your younger self the winning lottery numbers? You do not create a loop of infinite wealth. You create a new branch where your younger self becomes rich, while the original you from the timeline where you struggled simply vanishes from that story. Even accidental time travel could have cosmic consequences. A single misplaced footstep in the Cretaceous period could branch off a timeline where that particular insect was crushed, potentially altering evolutionary paths millions of years down the line in that new universe. The implications are staggering. It suggests that our present moment is the past for an infinite number of potential future time travelers. Any one of them could arrive here now, and by their mere presence or slightest action, cause our reality to fork into a new, divergent strand without any of us ever noticing. Our timeline would continue while a copy of our world, now hosting a time traveler, spins off into its own future. This view makes time travel logically consistent, but it also renders it profoundly lonely. You could never return to the home you left, only to a version of it that branched from the moment you departed. Every trip is a one-way journey into a new and increasingly alien reality. The past becomes not a place you visit, but a seed from which you grow a new cosmos. This branching nature of time travel forces us to confront a crisis that reaches to the very core of who we are. If every choice spawns a new universe, then somewhere, a version of you has committed every act you have ever considered, from the heroic to the horrific. This is the profound ethical dilemma of infinite selves. In a single universe, your decisions define your character and shape your legacy. Your choice to be kind, to be honest, to be brave matters because it carves a unique path through history. But in the multiverse, every path is taken. There is a universe where you donated your life savings to charity, and another where you kept every penny for yourself. One where you stood up for a stranger in need, and another where you turned and walked away. If all these versions are equally real, does the specific choice you make in this particular branch hold any moral weight at all? It can feel like the ultimate dilution of responsibility. Why strive to be good if a version of you somewhere is already being bad? This line of thinking leads to the unsettling concept of quantum morality. Some philosophers argue that in a many-worlds reality, the only meaningful ethical goal is not to make the right choice in your branch, but to increase the overall measure of good across the entire multiversal tree of your existence. Your responsibility expands from this single life to an infinity of lives that are all, in a fundamental sense, you, but this creates an impossible burden. How can you possibly account for the actions of an infinite number of other selves? The chilling answer is you cannot. This is where the idea of identity itself begins to fray. Are you truly the same entity as that other version of you who made a different decision 5 minutes ago? You share a common origin, a common past up to a point, but from the moment of the split, you have different experiences, different memories, and different futures. You are branches from the same tree, not the same branch. So while you may feel a strange kinship, you are not morally accountable for a separate being's actions, even if that being looks like you and shares your name. Your responsibility begins and ends with the choices made in the stream of consciousness you inhabit. The multiverse does not absolve you of moral duty in this life. It simply reveals that duty is local, tied to the specific timeline you are crafting. Your choices matter immensely, not because they are the only ones, but because they are the only ones that define the character of the person you are right now in this universe. The existence of other possibilities does not diminish the reality of the path you are on. It highlights its precious uniqueness. You are not living every life. You are living this one, and the weight of that single, focused existence is where all meaning and all morality truly resides. The weight of our single existence feels even heavier when we look up at a silent, star-filled sky and ask the universe's oldest question. Where is everybody? This is the Fermi paradox, and it leads us to a 13th secret that recontextualizes our cosmic loneliness. The universe is ancient and vast, with billions of planets that could support life. Statistically, intelligent civilizations should have arisen long before us and spread across the galaxy. Their signatures, whether radio signals, megastructures, or probes, should be everywhere. Yet we see and hear nothing but empty silence. The multiverse offers a chilling and elegant solution. Advanced civilizations do exist in overwhelming abundance. But we do not see them because we inhabit a specific, and perhaps very rare, branch of the quantum multiverse where they never emerged in our galactic neighborhood. Think of the cosmic history of our Milky Way as a story with countless decision points. At each juncture, a potentially life-bearing planet might avoid a sterilizing asteroid impact, or it might not. A promising species might develop technology, or it might go extinct. In the many worlds framework, every one of these quantum possibilities spawns a new universe. In the vast majority of branches, civilizations blossom, meet, and fill the galaxy with light and noise. But in a small subset of branches like ours, every roll of the cosmic dice came up quiet. In our specific timeline, the dinosaurs were not wiped out by an asteroid that narrowly missed. In our timeline, a neighboring star went supernova just close enough to disrupt early development, but not close enough to wipe us out. In our timeline, every potential rival or partner civilization in our galactic sector hit a quantum dead end. we are not in a universe devoid of life. We are in a universe where, through a specific sequence of quantum accidents, we ended up alone. This idea transforms the concept of a zoo hypothesis, where advanced aliens deliberately avoid us, into something far more passive and profound. We are not in a zoo they maintain. We are in a quiet wing of the cosmic library, a branch of reality that was isolated by chance, not by design. Our galaxy may be teeming with activity in most parallel realities, but we are listening from a silent room. This explains the silence without needing to invoke mysterious motives or universal filters of destruction. It simply means that in the grand tree of possibilities, we find ourselves on a very particular twig, one where the great cosmic conversation never got started in our corner of the woods. The eerie quiet is not a sign of our specialness, but of our specific, solitary history. It suggests that if we ever do make contact, it will be because we have somehow learned to reach not just across space, but across the branching streams of reality itself. The profound silence of our galaxy may not be the only whisper from beyond our bubble. The oldest light in the cosmos holds scars that point to a violent cosmic past. This is the 14th secret, written in the faint afterglow of creation itself. Just 400,000 years after the Big Bang, the universe cooled enough for light to travel freely for the first time. That primordial flash, stretched by eons of expansion into microwaves, still bathes the entire sky. It is called the cosmic microwave background, and it is the most detailed baby picture of our universe ever taken. For the most part, this afterglow is remarkably smooth, a near-uniform sea of microwaves, just as the theory of inflation predicts. But when scientists created exquisitely detailed maps of this radiation, they found strange, unsettling features that refused to fit the standard story. The most famous is a region in the constellation Eridanus, known simply as the cold spot. It is a vast, circular area of sky, significantly colder than the surrounding background, as if a giant patch of the early universe was missing a tremendous amount of energy. Its size and temperature are difficult to explain by known physics or random chance. Then there are the large-scale asymmetries. One entire hemisphere of the sky appears slightly warmer than the other, a cosmic lopsidedness that should not exist if the Big Bang was perfectly uniform. Another anomaly, dubbed the axis of evil, is an eerie alignment of hot and cold spots that seems to suggest a preferred direction in the cosmos, contradicting the fundamental principle that the universe has no center and no special orientation. So what could have caused these bizarre bruises on the face of the newborn universe? One of the most thrilling possibilities is that we are seeing the imprint of a collision with another universe. In the chaotic, frothing sea of eternal inflation, our bubble universe was not alone. As it expanded, it may have brushed against or even directly collided with a neighboring bubble cosmos. The energy of that colossal impact would have transferred into the fabric of our infant universe, creating a localized disturbance in the density and temperature of the primordial plasma. The cold spot could be the cosmic equivalent of a bruise, a region where energy was siphoned away by contact with another reality. The large-scale asymmetries could be the lingering tidal effects, a kind of gravitational wake from our bubble's violent passage through the multiversal foam. Picture two soap bubbles floating on the surface of water, gently drifting until they touch. At the moment of contact, their surfaces deform, creating a dimple and transferring energy. If our universe was one of those bubbles, the cold spot might be that very dimple, frozen into the sky at the moment of first light. These anomalies are not proof, but they are tantalizing clues. They are the closest thing we have to a fossil record of events that occurred before our universe, as we know it, even existed. They hint that our cosmos has a history beyond the Big Bang, a history written in collisions with other realms of reality. If these features are confirmed as signatures of a multiverse, it would mean we can literally point to a patch of sky and say, there, that is where we touched another cosmos. The silence of space is not empty, it is an archive, and we are only just beginning to learn how to read its most shocking chapters. These cosmic scars challenge our deepest assumptions about causality and the self. If our reality is one thread in an infinite tapestry, what does that mean for the choices we believe we are making? The 15th secret plunges us into the heart of a timeless philosophical battle, the question of free will in a multiverse. On the surface, the many worlds interpretation seems to annihilate free will completely. If every possible quantum outcome actually occurs, then for every decision you face, there is a universe where you choose yes and another where you choose no. Both are real. It appears that you never truly choose one path over another. You simply inhabit the branch where a particular predetermined outcome unfolds. Your feeling of deliberation is just an illusion, a story your brain tells as it rides a pre-laid track in the cosmic maze. This is a profoundly deterministic view, where the entire branching tree of reality was encoded in the initial conditions of the cosmos. You are not steering the ship, you are just a passenger on one of its countless possible voyages, but there is another, far more empowering perspective. What if your consciousness is not a passive rider, but the very mechanism of navigation? In this view, the branching of reality is real, but your stream of awareness does not travel down every branch. It selectively follows one path. The act of conscious choice is the process by which your awareness, your true self, selects which of the infinite branches to experience. You are not a leaf blown by a quantum wind. You are the wind itself, deciding which direction to flow. Your decisions do not create the branches, they choose which branch becomes your lived reality. This transforms you from a puppet of probability into the navigator of your own multiversal destiny. Your free will lies not in creating possibilities, but in consciously actualizing one specific possibility from an infinite menu. This debate finds a fascinating middle ground in an old philosophical idea called compatibilism. Compatibilism argues that free will and determinism are not mutually exclusive. You can have meaningful free will even in a predetermined universe, as long as you are able to act according to your own desires, motivations, and character without external coercion. Translate this to the multiverse. The entire branching structure may be determined, but the version of you in this branch makes choices based on your unique memories, your personality, your fears, and your hopes. That is genuine agency. The other you in the other branch makes a different choice based on a slightly different internal state. Both choices are free because both are expressions of the person making them in that specific timeline. The multiverse, in this light, does not destroy free will, it multiplies it. It guarantees that every possible expression of your character in every possible circumstance gets to be realized. You are not robbed of choice, you are granted the cosmic guarantee that every authentic version of your will is honored somewhere in the fabric of reality. The you who bravely speaks up exists, the you who hesitates and stays silent also exists. Both are true expressions of a complex being facing a moment of uncertainty. So, are you the author or a character in the story? The multiverse suggests you are both. You are writing this specific chapter with every choice, while an infinite library contains every other story you could have written. The weight of that authorship, the responsibility for this singular narrative you are crafting right now, has never felt more real or more profound. The profound weight of our choices leads to an experiment so bizarre it feels like reality itself is editing its own history. This is the delayed choice quantum eraser, and it reveals our 16th shocking secret. At its heart is a classic quantum puzzle, the double-slit experiment. When you fire a single particle, like a photon, at a barrier with two slits, it behaves like a wave, passing through both slits simultaneously and creating an interference pattern on a screen behind it. But if you place a detector to see which slit the particle actually goes through, that act of observation collapses the wave. The particle suddenly behaves like a single object going through only one slit, and the beautiful interference pattern vanishes. Now imagine a twist. You set up the experiment so that after the particle has already passed through the slits, but before it hits the final screen, you make a choice. You can either check which slit it came from, or you can erase that information. The staggering result is this: your later choice determines whether the particle, earlier in its journey, behaved as a wave or a particle. It is as if your present decision reaches back in time and rewrites the past behavior of the particle. This is the quantum eraser. In a single universe model, this suggests retrocausality, where the future influences the past, a notion that violates our most basic understanding of cause and effect. But within the multiverse, a far more elegant and less paradoxical explanation emerges. The particle does not have a single past waiting to be rewritten. Instead, from the moment it is emitted, all possible histories occur across a branching tree of universes. In one set of branches, the particle is measured at the slits, creating a particle-like history. In another, completely separate set of branches, it is not, creating a wave-like history. Both sets of events are equally real and are happening in parallel. Your delayed choice, your decision to look or to erase, does not reach back and change anything. It simply determines which branch of reality you, the observer, end up inhabiting. If you choose to check the which path information, your conscious awareness becomes consistent with the branch where the particle took a definite path. If you choose to erase that information, your awareness aligns with the branch where it behaved as a wave. The past is not malleable, it is multiple. You are not editing history, you are selecting which pre-existing historical narrative you belong to. This transforms the experiment from a paradox of time into a story of identity. It reveals that what we call the past is not a fixed record, but a flexible narrative that becomes definite only in relation to our present perspective. The universe is not a single, linear movie. It is an infinite library containing every possible version of every scene. Our measurements are not disturbing a solitary reality. They are us pulling one specific book off the shelf and reading its story, a story that was always there, waiting for a reader. This suggests a cosmos where consistency is more fundamental than sequence, where the present and the past are woven together in a seamless tapestry of parallel possibilities. The library of every possible past is not a random collection, but a system that may follow its own rules of inheritance and change. This brings us to a 17th secret that reimagines the multiverse not as a static landscape, but as a living, evolving ecosystem. It is the theory of cosmological natural selection proposed by physicist Lee Smolin. He asked a simple, radical question: what if universes can reproduce? And what if the laws of physics are not fixed but evolve over cosmic generations? His answer points to the most enigmatic objects in the cosmos: black holes. In Smolin's vision, when a star collapses into a black hole, the singularity at its heart does not mark an end. Instead, it becomes the seed for a new Big Bang, giving birth to an entirely new universe inside its own separate spacetime. This daughter universe would inherit the physical laws of its parent, but with tiny, random variations like a genetic mutation. Some of these new universes would be sterile, incapable of forming stars or black holes themselves. Others would be more prolific, their tweaked constants perfectly tuned to create an abundance of the very objects that spawned them. Over countless generations, a form of cosmic Darwinism would take hold. Universes that produce more black holes have more offspring. Universes that fail to reproduce fade into oblivion. Through this relentless selection pressure, the multiverse would evolve toward universes that are optimal for one thing, and one thing only: the production of black holes. This is a staggering inversion of perspective. We have wondered why our universe seems so finely tuned for life. Smolin's theory suggests we have been asking the wrong question. The constants are not tuned for us, they are tuned for the cosmic replication machines that are black holes. Life, in this view, is a cosmic accident, a byproduct of a universe that is exceptionally good at making more of itself. We exist in a universe that is a champion breeder in the multiversal tree of life. The abundance of stars, the specific strength of gravity, the very existence of carbon, all these things that allow for planets and people might simply be side effects of a physics that excels at gravitational collapse. It is a humbling and slightly dark realization. Our grand cosmos, with all its beauty and complexity, might ultimately be a finely honed black hole factory. This idea connects the largest structures in the universe to the smallest threads of possibility. Each black hole is not a dead end, but a womb for a new reality, each with its own slightly different story. The multiverse becomes less like a frozen library and more like a sprawling, growing forest, where every seed holds the potential for an entirely new world. This cosmic forest of black hole nurseries forces us to confront a fundamental flaw in the multiverse's grand design. If every possible outcome occurs in some branch of reality, then how can we possibly say that one outcome is more likely than another? This is the 18th shocking secret, the devastating problem of probability. In our familiar, single universe, probability is straightforward. When you flip a coin, there is a 50% chance of heads and a 50% chance of tails. This prediction is testable, and over many flips the results will roughly match the odds. But in the many worlds interpretation, both outcomes happen with absolute certainty. The coin lands heads in one universe and tails in another. So how do we recover the familiar fact that each result was equally probable? How do we get the 50-50 split back from a reality where everything happens? This is not a trivial puzzle. It is known as the measure problem, and it is perhaps the single greatest challenge facing the multiverse as a scientific theory. The core issue is figuring out how to count or weight the infinite branches of reality. Without a rule for this, the theory cannot make any quantitative predictions. It would tell us that a flipped coin lands both heads and tails, but it would be silent on why we should expect to see each result half the time in our own experience. Think of it like this. In an infinite multiverse, there are an infinite number of branches where you win the lottery tomorrow, and an infinite number where you do not. Infinity divided by infinity is undefined. So, are your chances of winning actually 50-50, or are they effectively zero? The answer depends entirely on how you decide to measure the size of those infinite sets of branches. Some methods of counting might show that branches where you win are vastly outnumbered by branches where you lose. Others might show them as equal. Without a fundamental principle from physics to tell us which counting method is correct, the theory loses its predictive power. This is the secret scientific tension at the heart of the multiverse. It offers a breathtakingly elegant explanation for the weirdness of quantum mechanics, but it stumbles when asked to deliver the hard numbers that science relies on. Proponents are actively working on solutions, suggesting that perhaps branches have different weights based on the amplitude of their quantum waves, or that our consciousness naturally samples from the branching tree in a way that recovers standard probabilities. But a universally accepted answer remains elusive. Until it is solved, the multiverse stands as a magnificent, compelling, yet frustratingly incomplete picture of reality. It can tell us what can happen, but it struggles to tell us what probably will happen in the world we actually experience. This uncertainty doesn't just haunt coin flips, it reaches into the very laws that shape existence. The measure problem's uncertainty echoes a much older human question, one that has defined civilizations. Our 19th secret confronts the ultimate metaphysical frontier, where cutting-edge physics collides with ancient spirituality. If reality is a vast, branching tree of infinite possibilities, what does that mean for our deepest beliefs about a creator, a soul, or a divine plan? The multiverse does not disprove the existence of God, but it radically reimagines what such a being's creation might look like. For many theologians, the traditional view of God is as a singular, purposeful architect of one cosmos. The multiverse stretches this canvas to infinity. Could a deity not be the designer of one universe, but the engineer of a multiverse generator, a system that spawns endless variations on the theme of existence? In this view, our specific universe, with its particular laws and history, is not the sole intended masterpiece, but one expression of a boundless creative impulse. The fine-tuning for life, rather than being a unique signature, becomes an inevitable feature across a near-infinite landscape of trial and error. Some find this vision diminishes the divine, making creation feel impersonal and mechanistic. Others see it as the ultimate testament to limitless creative power, a mind so vast it can conceive and sustain every possible reality simultaneously. The philosophical implications for the human soul are even more dizzying. In a branching multiverse, what happens to you? Does a single, indivisible soul follow one specific path, leaving the other branches inhabited by soulless automata that merely look like you? This feels unsettlingly arbitrary. Does the soul itself split and fragment, a piece of your spiritual essence accompanying each new version of you into each new branch? This suggests a dilution of self that challenges our sense of unique identity. Or perhaps the soul exists outside the branching structure altogether, observing the infinite tapestry of your lives from a higher dimension, untouched by the splits. This aligns with certain mystical and Eastern traditions that speak of a higher self or Atman that transcends individual experience. Philosophers and spiritual thinkers are only beginning to grapple with these questions. The multiverse forces a reconciliation between scientific materialism and spiritual concepts of consciousness. It provides a potential physical framework for ideas like reincarnation or parallel lives, not as supernatural events, but as features of a quantum mechanical reality. Your other selves in other branches are not past lives or future lives, but simultaneous lives, all unfolding now. This blurs the line between science and metaphysics in a way that is both thrilling and deeply disorienting. It suggests that the search for meaning is not confined to this single timeline, but expands across a cosmos of selves, each asking the same eternal questions from a slightly different vantage point. The silence we perceive may not be the absence of answers, but the echo of our own infinite voices. The infinite echo of our own voices might be whispering to us in the most mundane places. A surprising number of people share the same vivid yet demonstrably false memory. They recall the children's book series being spelled Berenstain Bears with an E, not the correct Berenstain with an A. Others swear the evil queen in Snow White said mirror, mirror on the wall, though the actual line is magic mirror. This collective misremembering of pop culture details has been dubbed the Mandela Effect, named for the widespread false memory of Nelson Mandela dying in prison during the 1980s. While psychologists explain this through social reinforcement and the fallible nature of human memory, the multiverse offers a far more thrilling, if speculative, possibility. What if these are not errors at all, but faint impressions, residual memories from a timeline that is almost identical to ours, but not quite? In a vast, branching multiverse, there are universes where the book series really was spelled Berenstain. There are realities where Darth Vader's iconic line was Luke, I am your father, instead of the actual no, I am your father. In those branches, the Monopoly Man does wear a monocle. According to this playful hypothesis, our universe and one of these nearly identical sister universes might have experienced a temporary quantum interference or a subtle merge at some point in the past. During that brief cosmic resonance, information, or perhaps even conscious awareness, bled across the boundary. We gained fleeting access to the memories of our other selves from that other timeline, creating a powerful sense of knowing something that is contradicted by the physical evidence in our own world. The memory feels real because in a very real sense it happened. It just happened there, not here. It is a glitch in the matrix of our isolated reality, a ripple from a neighboring stream in the multiversal river. This idea transforms a pop culture curiosity into a potential, if faint, echo of infinity. It suggests that the barriers between branches might be porous in ways we do not yet understand, allowing traces of could have been to seep into our what is. While firmly in the realm of speculation, it makes you wonder what other certainties in your life might be memories from a road not taken. The faint echoes of other timelines remind us that our own story is still being written, but every story, even a cosmic one, must have an ending. For our universe, the most widely accepted final chapter is a silent, frozen fade to black known as heat death. It is a conclusion of profound emptiness. Over trillions upon trillions of years, the last stars will burn out, black holes will evaporate into faint Hawking radiation, and all matter will decay into its most basic particles. The universe will expand into an ever colder, ever darker void, a thin soup of energy so diffuse that no work can be done, no structure can form, and no new event of any significance will ever occur again. It is the ultimate triumph of entropy, a state of perfect, unchanging equilibrium where time itself loses all meaning. This is the bleak, inescapable fate predicted by our current understanding of thermodynamics. Yet within the infinite canvas of the multiverse, even this absolute end might not be final. A startling possibility emerges from the quantum vacuum itself. In a universe that has reached heat death, there is still a faint residual quantum activity. Empty space, even in its lowest energy state, is not truly empty. It seethes with virtual particles popping in and out of existence due to the uncertainty principle. Given an literally infinite amount of time, an eternity so vast it defies comprehension, the most improbable quantum fluctuation becomes not just possible but inevitable. The universe could experience a spontaneous, random fluctuation so enormous that it creates a new region of ultra-dense, high-energy false vacuum. This tiny bubble, born from the ashes of the old cosmos, could then trigger a new period of inflationary expansion, birthing an entirely new universe with its own laws and history. This is the concept of quantum resurrection, a phoenix universe rising from the cold ashes of its predecessor. It requires no external creator, no violation of physical laws, only the inexorable mathematics of probability across infinite time. In the grand multiversal scheme, this transforms the narrative from a single, tragic story with one ending into an eternal cycle of death and rebirth. Our universe, with all its galaxies and life, might be just one episode in an endless series. The heat death is not the end of existence, but merely the conclusion of a single volume in an infinite library of cosmic epochs. Each new universe would be entirely disconnected from the old, with no memory or matter carried over, a fresh start in the purest sense. This cyclical view offers a strange, cold comfort. It means that even in the farthest future, when every star in our sky is gone forever, the potential for a new beginning always remains sleeping in the quantum void, waiting for its statistically inevitable moment to ignite. This eternal cycle of death and rebirth offers a cosmic perspective, but it forces us to confront a fundamental challenge. If other universes are, by their very nature, forever beyond our reach, can we ever truly call their study science? This is the 22nd shocking secret, the debate over falsifiability that stands as the greatest philosophical hurdle for the entire multiverse concept. The core principle of the scientific method is that a theory must make predictions that can, in principle, be proven wrong. If something is impossible to test, it risks drifting into the realm of untestable philosophy. Critics argue that the multiverse fails this basic test. How can we prove or disprove the existence of realities that are causally disconnected from our own, sealed away in their own space-time bubbles or branching quantum histories? If we can never visit them, never receive a signal from them, and never interact with them, is the multiverse just a fascinating story, rather than a serious scientific hypothesis. This is the elephant in the room, and it is a charge that multiverse proponents take very seriously. Their response is not to abandon science, but to redefine what evidence might look like in a cosmos of hidden realms. They argue that while we may never see another universe directly, we could detect its fingerprints left on our own. Think of it like a detective solving a crime without witnessing the event. They look for clues, for indirect evidence that points to a specific narrative. For the multiverse, the most promising clue is the possibility of a bubble collision. If our universe is one bubble in an eternal inflationary sea, and it collided with another bubble in the distant past, that collision would have deposited immense energy into the fabric of our young cosmos. That energy would leave a distinct circular pattern of temperature variations in the cosmic microwave background, a kind of cosmic bruise. Scientists have already been searching the sky for these exact signatures, analyzing the microwave background for anomalous rings or disk-like patterns that cannot be explained by standard cosmology. Finding one would be powerful, albeit indirect, evidence that our universe is not alone. It would be a shadow on the wall of our cave, cast by a fire burning in another cavern entirely. Beyond collisions, other forms of evidence are conceivable. If the laws of physics in our universe can be shown to be statistically optimal for producing black holes, as in cosmological natural selection, that could be indirect support for an evolutionary multiverse. Or if we ever develop a complete theory of quantum gravity that naturally and inevitably predicts multiple universes as a consequence, the explanatory power of that theory itself would be a form of evidence. The history of science is filled with concepts that were once considered untestable. No one has ever seen an atom directly, yet atomic theory is the bedrock of modern chemistry. We accept black holes and the Big Bang because their predicted effects match our observations perfectly, even if we cannot visit the singularity or rewind time to t=0. The multiverse, proponents argue, is on a similar path. It is a prediction that arises naturally from our best theories of inflation, quantum mechanics, and string theory. If those underlying theories continue to succeed in explaining the world we see, and if they persistently point toward a multiverse, then the idea gains credibility not from direct observation, but from its essential role in a coherent, predictive framework of reality. The goal is not to prove the multiverse with a single, smoking gun photograph of another cosmos. The goal is to build such an overwhelming case from indirect evidence and theoretical consistency that it becomes the most rational explanation for the universe we inhabit. The search is not for a doorway, but for the unmistakable draft seeping through the walls. This cosmic displacement is the source of our 23rd secret, a psychological tremor known as cosmic vertigo. It is the profound, dizzying feeling that arises not from looking down from a great height, but from looking out into an infinite reality where your own existence is endlessly repeated and refracted. For centuries, the Copernican revolution dealt a blow to human pride, showing Earth was not the center of the universe. The multiverse delivers a second, far more profound displacement. It suggests our entire cosmos, with all its 100 billion galaxies, is not the center of anything. It is one possibility among an endless sea of others. Your life, your loves, your most crushing failures and greatest triumphs are not unique events in a singular narrative. They are patterns occurring with infinite variations across the branching tree. This realization can trigger a deep existential shift, a form of multiversal awe that borders on spiritual terror. On one hand, it can feel liberating. The pressure of a single, perfect path evaporates. Every mistake you have made exists in a timeline where you did not make it. Every road not taken is a road fully traveled by another version of you. The weight of being the sole author of your destiny feels lighter, shared across an infinity of co-authors. Yet, on the other hand, it can evoke a crushing sense of insignificance. If everything that can happen does happen, then what is the point of this specific struggle, this particular joy? Does your courage in this branch matter when in another you were a coward? The very concept of achievement seems to dissolve into statistical noise. This is the core tension of cosmic vertigo, the oscillation between infinite freedom and absolute meaninglessness. The human psyche is not built to comfortably hold infinity. We are storytellers craving a singular narrative with a beginning, middle, and end. The multiverse offers no single story, only a library containing every possible draft of every possible book. To find our footing, we must re-anchor our sense of significance not in being the one and only, but in being the here and now. Your experience in this branch is not diminished because other experiences exist elsewhere. Its value comes from its immediacy, its vividness, its undeniable reality to you. The love you feel, the beauty you perceive, the choices you grapple with, they are authentic and consequential within this single thread of the tapestry. The multiverse does not erase meaning, it relocates it from the cosmic scale to the personal, from the eternal to the present moment. Your significance is not defined by your uniqueness in all of creation, but by the depth and integrity of your experience within this one precious version of reality you call home. This perspective turns vertigo into a strange kind of grounding, a reminder that infinity begins right here in the choices you make today. The stories we tell ourselves are rehearsals for reality. Long before equations could describe bubble universes, our myths and legends were already populated with alternate worlds, fairy realms, and ghostly doubles. Today, this ancient impulse has crystallized into a dominant force of modern culture. From the Oscar-sweeping chaos of everything everywhere all at once to the dazzling, animated dimensions of the Spider-Verse films, the multiverse is no longer a niche scientific idea. It is the backdrop for our most popular stories, and this is no accident. Art is performing a vital function, preparing our collective psyche for the radical, often unsettling, implications of a fractured reality. These narratives are a kind of emotional and philosophical training ground. While a physicist can explain the branching of quantum worlds, it is a film like Everything Everywhere All at Once that makes you feel the crushing weight of infinite possibility, the absurdity of divergent lives, and the ultimate, desperate search for meaning and connection at the center of that chaos. It translates the existential vertigo into a story about a mother, a daughter, and a bagel. Similarly, the Spider-Verse movies are not just about superheroes. They are profound meditations on identity and destiny. They ask, what makes you you if an infinite number of other versions share your name, your powers, and your pain? Is your story still special? The answer these films provide is a resounding yes. Your specific choices, your unique relationships, the particular love you hold for one person in one universe, that is what anchors meaning in an ocean of alternatives. This is a lesson that dry equations could never teach with such visceral power. Literature has been exploring this terrain for even longer. Authors like Jorge Luis Borges, with his Library of Babel containing every possible book, or Philip K. Dick, with his realities that shift and glitch, were mapping the multiverse long before it entered the scientific mainstream. They understood that the true shock of infinite worlds is not cosmological but human. It forces questions about regret, responsibility, and the nature of the self. By immersing ourselves in these fictions, we are unconsciously working through the psychological ramifications of a theory that might one day be confirmed. We are grieving the loss of a singular, privileged narrative and learning to find beauty and purpose in our own specific thread. This cultural explosion is more than entertainment. It is a collective coping mechanism and a visionary exploration. It suggests that perhaps the human imagination is not lagging behind science, but running ahead of it, intuitively grasping the emotional truth of a multiverse long before the math catches up. Our stories are the canaries in the coal mine of consciousness, testing the atmosphere of a new reality. And if they are preparing us for a multiverse, what might they be telling us about the final, and perhaps most important, secret of all? That personal, haunting question brings us to the final secret, the one that ties the infinite cosmos directly back to you. In a multiverse of infinite possibilities, are we truly alone? The answer is a profound and unsettling no. Statistically, given enough space, time, and random quantum arrangements, every possible configuration of matter will repeat. In an endless cosmic landscape, there is almost certainly another planet identical to Earth, in a solar system identical to ours, with a person identical to you. They have your memories, your face, your name. They might be sitting in a room right now, watching a video just like this one, feeling the same chill of recognition. But here is the crucial, mind-bending twist. That twin, that cosmic doppelganger, is not you in the way you think. Due to the endless branching of quantum possibilities, your paths diverged at some specific, invisible moment. Perhaps it was a single atom decaying a nanosecond earlier in their universe. Perhaps it was a stray cosmic ray that altered a single neural connection in their brain eons ago. From that point of divergence, your histories have been flowing apart, like two leaves dropped into a river at the same spot but caught by different currents. That other you might be nearly identical, living a life that mirrors yours in every detail you could ever check. Or they might be wildly different, their life shaped by a cascade of tiny changes into a story you would not recognize. They could be a celebrated artist in a world where they pursued a childhood passion you abandoned. They could be living in a city you have never visited, speaking a language you do not know, shaped by a history your world never had. This is the ultimate personalization of the multiverse. It is not just about alien civilizations in distant bubbles. It is about the infinite family of selves that your single life has spawned across the branching tree of reality. You are not a solitary entity. You are the focal point of a probability wave, the specific instance of a pattern that recurs across the cosmos. This final secret forces a radical redefinition of identity. You are not just the collection of atoms in your body or the specific memories in your mind. You are this particular thread of consciousness, navigating this specific sequence of choices and accidents. The other versions are real, but they are not you. Your experience, your awareness is anchored here, in this branch, in this now. The meaning of your life is not diluted by their existence. It is made more precious because this specific journey, with all its unique joys and sorrows, is the one you are living. The multiverse does not make you insignificant. It makes your conscious attention to this single, fleeting reality the most significant act of all. You are the universe experiencing itself in one of its infinite possible ways. And that is a secret worth knowing. This journey through 25 shocking secrets reveals a cosmos of breathtaking scope and profound strangeness. We have moved from the quiet split of a quantum decision to the thunderous collision of bubble universes, from the silent dread of Boltzmann Brains to the vibrant echoes in our own pop culture. Each secret a piece of a puzzle so vast it defies our everyday intuition. Together, they do not present a single, proven truth, but a spectrum of possibilities, each more dazzling and humbling than the last. They paint a portrait of a reality that is not a solitary stage, but an infinite theater running every possible play simultaneously. The multiverse is not a conclusion science has reached, but a frontier it is desperately exploring, a horizon of mystery that recedes with every answer we find. It challenges our deepest notions of self, destiny, and meaning, not to provide easy answers, but to expand the very questions we are capable of asking. The universe is far stranger, more interconnected, and more wonderfully bizarre than we ever dared to dream. So, as we close this exploration, we turn the final question to you. Of all these revelations, which secret reshaped your understanding of reality the most? Was it the quantum immortality of a conscious observer, the silent pull of dark flow from another cosmos, or the haunting possibility that you are reading this in one of an infinite number of identical rooms? Share your mind-blown moment in the comments below. If you are hungry for more journeys to the edges of understanding, make sure to subscribe. Our next dive into the cosmic unknown is already waiting.